Okay, awesome. Then let's go ahead and get into our lesson for today. So we'll get to, lesson 6.1. So our next unit is working with rational expressions. So rational expressions are basically like the polynomial version of fractions. So we've kind of been making this this comparison between numbers and polynomials. So like when we did long division, we related it to the long division we do with numbers. And so what we're going into is we're doing fractions with polynomials. So our lesson today is about how you reduce those rational expressions. And it's very similar to how you reduce fractions. So let's say that we had a fraction like 24 over 36. Well, the way that we would reduce this is we would divide the top and the bottom by 12 because they're both divisible by 12. And that would tell us that the reduced version of this fraction is 2/3. Now, these two fractions are the same amount. You know, like if you had a pizza and you cut one of the pizzas up into 36 pieces and you had 24 versus if you had 2/3, it's the same amount. And when we reduce rational expressions, it's going to be the same way. It's just a more simplified version of it. So this is the way that you probably learned how to reduce fractions. But there's another way that you can also reduce fractions that will be more helpful for when we're reducing rational expressions. And that is to get the fraction into factored form. So if I broke 24 down into its factors, I might say 24 is 4 times 6, 4 is 2 times 2, 6 is 2 times 3. So I could write this fraction as 2 times 2 times 2 times 3 over, and if I split 36 up into factors till it's in fully factored form, I would end up with 2 times 2 times 3 times 3. Is everybody good with how this fraction is the factored form of this fraction? So one way you could reduce this fraction is you could divide and cancel out the common factors. So 2 divided by 2 equals 1. 2 divided by 2 equals 1. 3 divided by 3 equals 1. And the factors that are left over are the reduced version of that fraction. So both methods work when you're reducing fractions. This is the method that's going to make, it will make it easier to reduce polynomial fractions. So what we're going to do with our polynomials is we'll get it into factored form, and then we'll cancel out the factors that are in common. So for example, let's say that we had this rational expression. So we have a fraction with a polynomial on the top, a polynomial on the bottom. The way that we would reduce this is we would first of all get these polynomials into factored form. So x squared minus 49 is a difference of squares because they're both perfect squares. So you could factor this to be x minus 7 times x plus 7. Is everybody good with that? I know it's been a little while since we've been in class. So that's the difference of squares factoring. And then on the bottom polynomial, both terms have a 3 in common. So I can factor out the greatest common factor, which is a 3. And that leaves me with x minus 7. And now that they're both in factored form, now I can cancel out the factors they have in common. So I'll cancel out the x minus 7 because x minus 7 divided by x minus 7 will equal 1. And the simplified version of this rational expression is x plus 7 over 3. So this is the reduced version of the rational expression. And if you were to graph this, like if you said y equals this and you graphed it on a coordinate plane, and then if you did y equals this and you graphed it, they would look like the exact same graph. The one thing that you do need to be aware of whenever you're working with rational expressions is that you cannot have division by 0. So x can be anything except for 7 in this case, because if x equaled 7, you would have 7 minus 7, which is 0 times 3, and that would create division by 0. And when you divide by 0, that's an undefined number. And so that's one thing you need to be aware of when you're working with rational expressions is that you can't divide by 0. And I'll go through some homework problems where it touches on that. So that's pretty much the main idea of today's lesson. We're learning how to reduce rational expressions by getting the polynomials in the top and bottom of the fraction into factored form, and then you cancel out any common factors that there are. Any questions on this so far? Okay. So why don't you guys try this one based on what you know about factoring? See if you can reduce this rational expression. All right, so I factored this in my head, so I could be wrong. Is this what you guys got for the factorization of the top polynomial? Okay, and is this what you got for the bottom one? Okay, awesome. So now that it's in factored form, let's first look at what our variable restrictions are. So what can x not be if we want to avoid division by 0? Yep, so x cannot equal -8, because if x did equal -8, we would get 0 times -5, which would have division by 0. What's the other thing that x cannot equal? Yep, -3. So these are the two numbers that x cannot be. It can be any other number though. Okay, so now that we found our domain restrictions, then we can simplify the expression by canceling out the common factors, because x plus 3 divided by x plus 3 would cancel out to 1. And this means that our simplified expression would be x minus 6 over x plus 8. And that's fully simplified. You can't simplify that any further. And so that would be the simplified or reduced version of this rational expression. Any questions on that? Are you going to say cancel out the x's? Yeah, that's a good question. So the reason you can't cancel out the x's is because these are being subtracted or added. You can only cancel out things across division if those things are multiplied. So that's the whole point of like why we want to get it in factored form, is so you can cancel them out. Good question. Yeah. Why did you cancel out? So I didn't cancel out -8. I'm saying that x cannot equal -8. And the reason it can't is because if it did, then you would create division by 0, and dividing by 0 creates an undefined number. Yeah. Any other questions? Okay, cool. So basically that's everything you need to know for the lesson. I would say the most difficult part of the lesson is just the factoring. But you guys have also been doing lots of factoring, so hopefully it should be relatively easy. Just remember, when you're factoring, the first thing you always want to look for is if there's anything that all of the terms have in common. So always look and see if there's a greatest common factor. So like in this case, you'd say like, oh, 32 and 2 both have a 2 in common. And these two terms have a y in common. So you would factor that out and you'd get 2y times 16 minus x squared. Then you could factor that further because that's a difference of squares. So always factor out the greatest common factor first. and then look at what's left and say, is it a difference of squares? Is it a trinomial? Is it something where I need to do factoring by grouping? Or I think there's one problem where you'll have a sum of cubes or a difference of cubes, in which case you'll use the sum or difference of cubes formula. So that's pretty much it for your lesson. I have a couple examples that I thought might be helpful to go through. So if you want to open up your homework, I'm going to start on question 13. Okay, so if I want to reduce this fraction or this rational expression, the first thing I need to do is get it into factored form. So I have things that are multiplied together, because that will allow me to cancel them out. So for the top polynomial, I noticed that I have a squared minus 16, which is 4 squared. So that's a difference of squares, which means that I can factor it to a minus 4 times a plus 4. And that's just using the difference of squares formula. And then on the bottom, I can't factor that one any further. So I just have 4 minus a. And if I want to, I could put parentheses around it. So when I look at this polynomial here, I notice that none of the factors are the same. So I can't cancel anything out. But this factor and this factor are exact opposites. Because in this one, I have a positive a, but this one's a negative a. In this one, I have a negative 4, but this is a positive 4. And so what that means that I could do is I could factor out a negative 1 from the bottom. So if I did 4 divided by negative 1, that would be negative 4. Negative a divided by negative 1 equals positive a. And that makes it the same as a minus 4. Does that make sense? So you know how you can factor anything out of a number? So like these two numbers don't have, or these two terms don't have anything in common, but they do have a 1 in common, right? And you could also say they have a negative 1 in common. So if I pull a negative 1 out of both of these, I would get negative 1 times negative 4 plus a. Because if I were to distribute the negative 1 to these two, I would end up with this, right? The reason why I would want to do this is because negative 4 plus a is the same as a minus 4. And that makes it so that I can cancel these two out. And so on there's actually a couple problems on your homework where you'll need to do that, where you might have two factors that are almost the same, but they're exact opposites of each other. If that happens, then just factor out the negative 1. Any questions on that? So once I do that, then my answer is going to be a plus 4 divided by negative 1. Well, I could distribute that division by negative 1, which would just give me negative a minus 4. And so that would be the most simplified version of this rational expression. And that's what I would put in here. Any questions on that? Okay, now the second part is what we were talking about, how you have to restrict what the variable can be so you don't get division by 0. And notice that it's the variable restrictions for the original expression. So you don't look at the simplified one, you look at the original expression, and it's easiest if you look at it in factored form. So you look at it and you say, okay, well, what values of a would create division by 0? In the original expression. 4, right? Because 4 minus 4 would give you 0. And so that means that a cannot equal 4 because I don't want to get division by 0 because dividing by 0 gives you an undefined answer. So that's how you would do question 13. And again, there are a couple other problems where you'll need to factor out a negative in order to be able to cancel out the terms. But the only time you'll do that is if your two common, or if your two factors are almost exactly the same, they're just opposites of each other. So that's question 13. The other one I want to do is question 15. So on this one, the top polynomial is not in factored form. Like you do have these two sets of parentheses, but those sets of parentheses are not multiplied together. And remember, factors are things that are multiplied together. And in this case, these are being subtracted. And so that means that I'm going to simplify this entire polynomial and then factor it from there. So the way that I simplify that is by getting rid of parentheses. So this set of parentheses technically has a positive 1 out in front of it. And so if I distribute the positive 1, I just get x squared plus 2. So those parentheses didn't really add anything to the polynomial. But in this one, I'm subtracting this entire thing. So I need to distribute that subtraction or that -1 to both of the terms. So I get negative a squared and -2. And this whole thing is still over x minus a. And when I simplify this, well, 2 and a -2, if you add those together, that equals 0. So you end up with x squared minus a squared over x minus a. And x squared minus a squared is a difference of squares. So you could factor that to x minus a times x plus a all over x minus a. And both the top and the bottom of the fraction have an x minus a factor, so you can cancel those out. And your simplified rational expression would be x plus a. So this entire rational expression simplifies to just be x plus a. Any questions on that? So these are just like some special cases that I wanted to look at because they're kind of unique. But the main idea is you get the top and the bottom of the fraction into factored form, and you cancel out the factors that they have in common. And on some of the problems, like on question 5, they already have it in factored form, because what this means is you have x plus 4 times another x plus 4, because x plus 4 is squared, times x plus 1. Then on the bottom, you have 2 x plus 1s and an x plus 4. So that one's already in factored form. You just need to cancel out the factors that they have in common. To 15? Mm-hmm. Cool. Yeah. So some of them, they'll give it to you in factored form. In other ones, you'll need to factor them. On question 7, do you guys know what method you would use to factor those polynomials? Yeah. Yep, you'd use factoring by grouping because there's 4 terms. So like you would split this into 2 groups. The first group has a b in common, and you'd have b times d minus 1. The second group doesn't have anything in common, so you can say it has a positive 1 in common, which also leaves you at d minus 1. And so the top part of that fraction would end up factoring to d minus 1 times b plus 1. And then the bottom part of the fraction would factor to something similar. But just remember, if there's 4 terms, factoring by grouping is a good place to start. If there's 3 terms, do the trinomial trick. If you've got a difference of squares or a difference of cubes, you can use the formulas for those. But whenever you start factoring, you always want to start with seeing if they have, like, if all of the terms have something in common. So that's it for the lesson. If you guys have any questions or if you'd like any help factoring any of the polynomials, let me know. Because really the hardest part of this assignment is doing the factoring. The new stuff isn't that bad because you just cancel out the factors that they have in common. So let me know if you have any questions, and I can also answer any questions from previous lessons if that would be helpful.